Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello dear students and welcome to first year science online classes. We are going to start a new chapter today, and that is complex numbers. When I explained to you the outline of the syllabus, I referred to this particular chapter, and I said this extends the set of real numbers. We know for now the set of natural numbers. Okay, so they are called counting numbers. You know them, 1, 2, 3, 4 and all. Okay, so infinite set, and then we have the set of whole numbers, which includes 0 and nothing extra. So there is only one number that is extra, is the number 0. And then we have the integers. You can refer them as capital letter I or Z. Okay. Now, how does this set look like? You have the positive numbers, natural numbers, and then you have the negative numbers as well. So these are called integers. All right. So you have infinitely many negatives and infinitely many positive numbers, and that is referred as the set of integers. And then as we go along, we have the set of rational numbers. So rational numbers are of the type p by q, where q is not equal to 0. And what are p and q's? P and q belong to the set of integers. So you have to take two integers, and if you write that in the form of p by q, where q is not equal to 0, and there is one more condition, p and q should not have common factors. So if they do not have common factors, then that is referred as a rational number. Okay, so q is the set of all rational numbers. Then you see, if you have rational numbers, there must be irrational numbers, correct? So what are a few examples of irrational numbers? For example, square root of 2, square root of 3, pi, and all those are referred as irrational numbers. Why? Because they cannot be expressed as p by q form. Okay, so you cannot represent them in the form of p by q, but they are not integers. Okay, so those numbers are called irrationals. You have non-recurring decimal points there. All right. So that is about irrationals. Now what comes is the real numbers next. So real number, the set of real numbers consists of both rationals and irrational numbers. So you have all the numbers in the set of real numbers. So just to give an example, you have real numbers like 0.01, 0.001 is also there, 0.001. Okay, so like that you have infinitely many real numbers. You have both rationals as well as irrational numbers there. Now if I explain this in the form of a geometric representation, see, this is the set of natural numbers. Okay, a small set. Then you have little bigger set, and that you can name it as whole numbers. Then you have the set of integers. Okay, so that is little more bigger, and then you have the set of rational numbers. Okay, so the biggest set that we know for now is the set of real numbers. See, when we come to complex numbers, so that is the biggest set that we know. Okay, so far you know only till real number set. Now what are we going to study next is the biggest set, and that is set of complex numbers. Okay, so like the set of real numbers includes both rationals as well as irrationals, the set of complex numbers include both real numbers. Okay, all the real numbers are there in the set of complex numbers, and little extra numbers which are called imaginary. Okay, so real as well as imaginary, you have them in the complex number. Now that is about the extension of the set of real numbers. Now let us understand why do we need those complex numbers. If you don't need, then we don't have to study them, right? So why do we need them? So that makes it clear the necessity of this complex number set. Well, see, basically these numbers are helpful for us to solve particular equations. Okay, so when you apply them in the real life situations, you need those numbers to find the roots of let us say a linear equation, or you can get the roots of a quadratic equation or a cubic equation as well. Okay, it goes on like that. Anyway, now so basically let us say you have x square minus 1 is equal to 0, a simple quadratic equation. So what is the what are the roots of this quadratic? Since it is quadratic, it should have two roots, two zeros, alright, two values of x which satisfy this equation. Well, how do you solve it? This is the simplest one. So you can take you can write two factors like this. This is a square minus b square, therefore a plus b in the sense x plus 1 in this case, and x minus 1, that is equal to 0. Now product of two factors is 0, therefore either the first factor must be 0 or the second factor must be 0, right? Therefore as we continue, we get x is equal to minus 1 and x is equal to plus 1. So what do you conclude? Therefore x is equal to plus or minus 1. Well, so either minus 1 or plus 1 are the zeros of this particular quadratic equation, or we call them roots of the quadratic equation, right? Okay. Well, so you have x is equal to plus or minus 1, therefore if you put minus 1 square is 1, 1 minus 1 will be 0. So the other number is plus 1, so if you put plus 1 also, 1 minus 1 square is 1, 1 minus 1 will be 0. So it satisfies, correct. Now if suppose I have a quadratic equation of this form, alright. So I have a quadratic number of this form. Now what happens here is you have x square is equal to 1, I mean x square is equal to minus 1. So what is the value of x? See, you have to take the square root both sides. So if you take square roots here, right, so what do you need to take? Plus or minus. See, when you take square root, it should be plus or minus, right, because there will be two values which satisfies the quadratic equation, and this will be minus 1, right. You could do that here as well. See, I could do this as x square is equal to 1, therefore x is equal to plus or minus square root of 1, therefore it is plus or minus 1. So this way also I could solve it. This is a better understanding. Okay. This is the simpler or the easiest way of solving it. Well, Now we have stuck at a point here. So why am I saying we are stuck? Because we have studied so far that square root of negative number does not exist, is it not? Okay, so square root of a negative number, if it does not exist, then this quadratic equation does not have a solution. This quadratic equation does not have the roots. Okay, but in real life situations we come across, when we solve the problems, you come across this kind of quadratic equation for sure. Okay, so if you come across this kind of quadratic equation, how do you proceed? What is your conclusion? You just say, well, this equation does not have a solution. So therefore, they have devised a method of solving such quadratic equations by writing this square root of, by taking square root of minus 1 as small letter I. Okay, so I refers to imaginary. Okay, I refers to imaginary number. So square root of minus 1, we have taken it as I. Therefore, this will be plus or minus I. Plus or minus I is the answer of this quadratic equation, solution of this quadratic equation. Okay, so because of the necessity to find the solutions of the quadratic equation, we have taken or considered square root of minus 1 as I. I hope you understood. That is the basic of this complex numbers. Now let us come to the definition of the complex number. I is an imaginary number. Okay, all right. Now how do we define a complex number? A complex number or any number of the form, a complex number of the form a plus ib, where a and b belong to the set of real numbers. So what are a and b? Real numbers. You can take 1 and 2 here. Okay, so likewise, or any real number, you can take 0.1, you can take square root of 2 here, or whatever. Well, okay, let me complete the sentence. Any number of the form a plus ib, where a comma b belong to R, and I is equal to square root of minus 1 is called a complex number. Well, so this is the definition of a complex number. Well, so I hope you understood what is the meaning, how do we define a complex number. Any number, okay, of the form a plus ib. A can be 0 or even b can be 0. Okay, so simple example. So for example, 2 plus 3i is a complex number. Okay, you can take negatives. So let us say minus 1 plus root 2i is a complex number. Okay, so it goes on like that. Even if you write 2i, is it a complex number? Yes, because it is 0 plus 2i. Or if you write just 2, okay, let me change the number. Why to take 2 all the time? So shall I take 5? Okay, so 5, is it a complex number? Yes, because it is 5 plus 0i. Because a and b must be real numbers. Now 0 is a real number, 5 is a real number. So even if you write 5, just 5, okay, without writing this, that is also a complex number. So please remember, all the real numbers are complex. Okay, all the real numbers, you can write any real number, that is by default a complex number. Okay, so there are additional numbers which are not real. This is not a real number. because I is square root of minus 1. Square root of minus 1 is not a real number. Okay, it does not belong to the set of real numbers. So please remember that. Okay, so these are additional numbers. So all the real numbers are also complex. So these are a few examples of a complex number. Well, now you have to learn a few terms here. How do we represent a complex number? Alright. So usually a complex number is represented by, okay, so if z is equal to a plus ib, see, a complex number is represented by the symbol z, okay, usually. Okay. Then what is a? Okay, then a is called the real part, is called the real part of z, and b is called the imaginary part. And how do we write them? See, real part is written as real part of z. This is the symbol, remember that, RE of z. And B is written as imaginary, so IM of z. So these are the symbols. So whenever you see a symbol like this, you must remember that this is real part of z. Now tell me, what is the real part of this complex number? Okay, so for this complex number, real part of z, if you are writing this as z, real part of z is equal to 2. Similarly, imaginary part of z is equal to 3, is equal to 3. Well, I hope you understood this. Okay, so that is about the symbols and the notations. Okay. Now next, in the complex numbers, let us say you are saying two complex numbers are equal. So now there is a question, there arises a question, when do you say two complex numbers to be equal? Alright, so if z1 and z2 are two complex numbers, and z1 is equal to z2, then their real parts must be equal and their imaginary parts also must be equal. Okay, so please remember this. When do you say z1 is equal to z2? Imagine z1 is equal to a plus ib, okay, and z2 is equal to c plus id. So I am taking two complex numbers here, z1 and z2. Now if z1 is equal to z2, then what must be equal? Real part. What is the real part of z1? A. So real part of z1 is a and real part of z2 is c. So a and c must be equal. Their real parts must be equal. So real parts are a and c, and their imaginary parts also must be equal. imaginary part is b, not ib. Remember, imaginary part is only b. Remember that. Okay. So this is b, and here you have d. So these two must be equal. So if they are equal, then we say the complex numbers to be equal. Otherwise, we don't say they are equal. So let us solve one example problem just to make this concept clear. Well, so consider one example. If 4x plus I into 3x minus y is equal to 3 plus I into minus 6 okay. Minus 6. Then find the values of x and y. Then find the values of x and y. That is the question that is asked. So solution or answer. Okay. So now understand, two complex numbers are equal. So if complex numbers are equal, their real parts must be equal. So real part 4x and the real part here 3. So they must be equal. Okay. So since complex numbers are equal, their real and imaginary parts must be equal, then their corresponding okay. Therefore, 4x must be equal to 3, which implies x is equal to 3 by 4. So x is equal to 3 by 4 there, and imaginary parts must be equal. So what is the imaginary part here? 3x minus y, and the imaginary part is minus 6. So similarly, and 3x minus y must be equal to minus 6, right? Now we know the value of x. Let us substitute here. So the value of x is 3 by 4 and minus y is equal to minus 6. Alright. So what we can do is, 9 by 4, and this minus 6, you can bring it this side, becomes plus 6, and then you can bring this minus y to the right hand side, and that becomes plus y. Therefore, now what is left is just simplification of a fraction here. Okay. So take the LCM 4. So if you take the LCM 4, you must multiply 4 here. So 9 plus 24. So therefore, y is equal to 33 by 4. Okay. So you are getting x is equal to 3 by 4 here, and y is equal to 33 by 4 here. Well, so that is about the concept of complex numbers. Understand, first the definition of a complex number. Alright. Before that, why do we need the complex numbers? And we took square root of minus 1 as I, and then we defined a complex number as a plus ib. And what is the symbol that we are using for a complex number? Z. Alright. And what is the set of a complex number? Set of complex numbers is capital letter C. Okay. So, set of complex numbers is capital letter C. And when do you say two complex numbers are equal? If their corresponding real parts are equal and the imaginary parts are equal, then we say two complex numbers equal. So, if two complex numbers are equal, their real parts are equal, their imaginary parts are equal, hence we can find the values of x and y. Well, so that is about the introduction of complex numbers. In the next class, we will study how do we add two complex numbers, right? How do we subtract and how do we multiply two complex numbers. So, that is algebra of complex numbers. Well, so thank you for watching.
Don't forget to like our video and subscribe our YouTube channel for all the updates.